In this problem, we're given a quadratic function, and we want to rewrite this equation in general form and standard form. Let's go ahead and solve this for general form first. The function we're given is g of x is equal to 13 plus x squared minus 6x. The only thing that we want to do is we want to rewrite this so the x squared term comes first, the x term comes second, and the constant term comes last. So this is going to be x squared minus 6x plus 13. And this is our quadratic function in general form. Now let's go ahead and look at the standard form. Recall that a quadratic function is in standard form if we have a times x minus h raised to the second plus k. In the previous problem, we saw that our a is given by the number in front of the x squared term, which is 1. So the only thing that we need to find is we need to find h and we need to find k. H is equal to b divided by negative 2a. This is also written as negative b divided by 2a, and you'll mostly see this in this form. So plugging in for b, we'll get that this is equal to a negative 6 divided by 2. So this is going to be equal to 3 after you simplify it. Then to find k, we're just going to use the formula. Let's go ahead and use the formula that k is equal to c minus a times h squared. Since we know what h is just 3, we can plug everything into this formula. This is going to be equal to 13 minus 1 times 3 raised to the second. After simplifying this, you should get that this is just going to be equal to 4. So we have our h, we have our k, we have our a. Plugging this into our formula, we'll get that this is then equal to an x minus 3 raised to the second plus 4. And this is our equation in standard form. In this example, we want to find the axis of symmetry and the x-intercepts of the given quadratic function if they exist. So let's go ahead and first try to find the x-intercepts. So anytime we're looking for a geometric piece of information, even if we're doing it algebraically, it helps to have a picture. So suppose we know that the parabola opens up, and maybe the parabola looks like this, and so we're trying to find the points of the parabola that intersect the x-axis. That means we want our y value to be equal to 0, so we're going to set our function equal to 0. Now we want to find the numbers x that make this equation true, but this is pretty difficult to do. So instead of trying to factor this, let's go ahead and apply the quadratic formula. Recall the definition of the quadratic formula is that x is going to be equal to plus or minus, this is going to be negative b plus or minus the square root of b squared minus 4ac divided by 2a. Let's plug this in. We'll have x is equal to a negative b, x is a negative 6 plus or minus the square root of a negative 6 minus 4 times 2 times 7, all divided by 2 times 2. There's one thing that I didn't put here. We should have a squared term there. Let's go ahead and check the determinant real fast. So the determinant of our quadratic formula is the number underneath the square root. Then the determinant of this function is given by a negative 6 raised to the second power minus 4 times 2 times 7. Simplifying this, we'll get that this is going to be equal to 36 minus 56, which is equal to a negative 20. Recall that the determinant tells you if you have any real solutions or complex solutions, and since the determinant of this function is negative 20, that means that this function has no solutions that are real numbers. So let me start a new page and write some of this down. Okay, Again, since the determinant is less than 0, this implies that the equation has two complex solutions. This means that x has no real solutions, and this implies that f of x has no x-intercepts. One fact about f of x having no x-intercepts, and also that we know that it opens upward, means that the parabola is going to either lie in quadrant 1 or quadrant 2, or both. Let's go ahead and look at the second part of the problem. And in the second part, we want to find the axis of symmetry. Again, let's just go ahead and recall what the axis of symmetry is. We know that our parabola is somewhere up here, since it has no x-intercepts. And the axis of symmetry is going to be the vertical line that goes through the vertex, hk. This means that the equation of our axis of symmetry is going to be x is equal to h. So the only thing that we need to compute is our number h, and h is given by a negative b divided by 2a. So this is going to be equal to a negative 6 divided by 2 times 2, which is, if you simplify this, you'll get that this is 3 over 2. So the axis of symmetry is given by x is equal to 3 divided by 2.